Welcome to the first module in this session, Understanding Cognitive Bias. The goal of this module is for learners to understand how failed heuristics contribute to cognitive biases and diagnostic errors. The learning objectives are to explain how radiologists use heuristics to make decisions, describe the differences between type 1 thinking and type 2 thinking, and discuss how type 1 thinking can contribute to diagnostic errors. Cognitive biases are prevalent in medicine and radiology, contributing to a significant number of diagnostic errors. Errors related to cognitive biases are both predictable and avoidable. The first step towards reducing cognitive errors is to understand the processes underlying problem solving in conditions of uncertainty. The dual process theory has recently emerged in the psychology literature as the dominant model for cognitive operations and suggests causal reasons for diagnostic errors. This theory takes into account that there are two systems driving human decision-making. Type 1 thinking is intuitive, heuristic, reflexive, and unconscious, like pattern recognition. An example is when a radiologist identifies an inflamed appendix in a patient with right lower quadrant pain. Type 2 thinking is analytical, deductive, deliberate, and rule-based. An example is when a radiologist finds a new liver lesion in a patient with both cirrhosis and pancreatic neuroendocrine tumor, and has to determine whether it represents hepatocellular carcinoma or neuroendocrine metastasis. Underlying both of these processes is the cognitive miser theory, which states that to conserve energy, we try to use type 1 thinking as much as possible. Let's define heuristics. These are mental shortcuts that allow rapid problem solving based on assumptions and past experiences when there is uncertainty. We all rely on heuristic principles to reduce complex tasks and predicting values into simpler judgment operations. Let's look at a real-world example. There are two hospitals in a small town. In the larger hospital, approximately 45 babies are born each day. And in the smaller hospital, approximately 15 babies are born each day. About 50% of all babies are boys, but the exact percentage varies day to day. Over 1 year, which hospital had more days in which more than 60% of babies were boys? The larger hospital, the smaller hospital, or about the same for each hospital? The correct answer is 2, the smaller hospital. This is because there are a smaller number of babies born in the smaller hospital, resulting in higher variability in the percentage from day to day. If you answered this correctly, you likely used type 2 thinking to determine the answer. When posed to undergraduate students, most answered 3, about the same. This is an example of failed heuristics, or type 1 thinking, leading to a cognitive error. Now let's look at a radiology example. This is a CT exam in a 71-year-old patient with hematuria. The radiologist identifies a calcified desmoplastic mesenteric mass and a hypoenhancing liver lesion in segment 4. In this case, the radiologist correctly diagnosed small bowel carcinoid with a mesenteric nodal metastasis and liver metastasis. This is a good example of the type of pattern recognition that helps experienced radiologists arrive at a diagnosis. A liver MRI was performed to further evaluate the liver lesion. A second radiologist interpreting this examination identified an enhancing lesion in the L3 vertebral body that was concerning for an additional metastatic deposit. Let's look at this more closely. In the left column, there's a post-contrast T1 sequence and a post-contrast CT image showing the L3 vertebral lesion. This lesion is slightly sclerotic on CT, which is not unusual for a carcinoid metastasis. In the right column, you see the liver lesion on diffusion-weighted imaging and the ADC map. This lesion shows restricted diffusion. It's bright on DWI and dark on ADC. However, when we look at the spine lesion in the middle column, you see that it is bright on both diffusion-weighted imaging and ADC, which means that it is not restricting diffusion. This would be very unusual for a carcinoid metastasis. A confirmatory test was performed. On the PET dotatate study, we see avid uptake in the liver lesion that is compatible with carcinoid metastasis. However, we don't see any uptake in the spine lesion, which means that it is not a spine metastasis. This has significant implications for the patient, because if there is spine metastasis, he can no longer be treated for cure. Type 1 thinking and pattern recognition helped the first radiologist quickly and accurately diagnose metastatic carcinoid tumor on the CT exam. Type 1 thinking and pattern recognition caused the second radiologist to incorrectly assume the spine lesion was a metastasis on the MRI. Because of failed type 1 thinking, the second radiologist did not realize that the spine lesion had different imaging characteristics than the liver and mesenteric lesions. Let's look at a different real-world example. One group was asked to estimate the product of the following equation within 5 seconds. 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Another group was asked to estimate the product of a similar equation within 5 seconds. The exact same equation, but in a different order. The median estimate for the first equation was 2,250. The median estimate for the second equation was 512, whereas the correct answer was 40,320. This is an example of anchoring bias, and you can see how the first number of the equation influences the estimation. Let's look at a radiology example of anchoring bias. This is a CT exam in an 80-year-old patient with persistent intermittent gross hematuria on dual anticoagulation therapy. The indication is to assess for malignancy. The imaging you're looking at is actually a CT performed 3 months ago on this patient. The radiologist interpreting the current exam looked at this prior imaging, and based on the hypoenhancement of the right kidney with associated perinephric stranding, felt that this likely represented pyelonephritis. When the radiologist then went to look at the current examination, he noticed that there were non-enhancing areas in the right kidney and determined that this likely represented progression of pyelonephritis to renal abscess. When he identified renal vein thrombosis, he attributed that to the infectious process. When he then identified new pulmonary nodules in the lung bases, he thought those likely represented septic emboli related to the renal abscess. However, in this case, the findings represented infiltrative transitional cell carcinoma. Anchoring bias reflects the undue influence that an initial interpretation has on the evaluation of subsequently collected information. In this case, the radiologist incorrectly came to the conclusion that the patient originally had pyelonephritis, and when he encountered new information that was not consistent with pyelonephritis, he was unable to change the diagnosis due to anchoring bias. The characteristics of type 1 thinking in this case is pattern recognition of pyelonephritis in the prior exam, which was incorrect, ignoring the clinical indication of gross hematuria and concern for malignancy, and ignoring pertinent data available in the electronic medical record. The patient did not have an elevated white blood cell count during either exam. To summarize, radiologists use heuristics to make decisions when there is uncertainty, and this approach often helps us arrive at the correct diagnosis. Type 1 thinking is fast, like pattern recognition. Type 2 thinking is slow. It's analytical problem solving. Failed heuristics or errors in type 1 thinking contribute to cognitive biases and diagnostic errors. In the next module, we will review different types of cognitive biases that can result in diagnostic errors.